Tracy. Is Tracy here? No. Okay, so let's start, and I think we will be done with those topics. Today we conclude. The part of geometry, it's a part that is not studied at all, okay, to be honest. We're going to see like the geometry you should know, of course. You will complete the part of geometry with the forum of this week. In the forum of this week, what you will do is like investigate um, yeah, investigate some properties, some rules, some theorems or corollaries related with the elements we may see today about geometry. But let's conclude this first part of the equations, okay? I mean, of the algebraic expressions, which at the end are connect with equations. It's a topic that is pretty interesting because here we will see the applications of these ones, okay? So um, let me see, there are some classmates trying to join. Karen and Tracy, that's okay. It's just missing Mercedes. Okay. Now I think we are ready, so here we go. When we talk about the equations, well, we will see what those equations are about. Essentially are, or it's a continuation of the algebraic expressions. But we work with equation in math every moment, so it's a topic that we already see. Just that now we're gonna see like, or we're gonna mix it with the algebraic expressions, the operation techniques we have been working with. It's so simple. So what are the objectives? First of all, define what is a mathematical equation. Then differentiate the algebraic equations and the arithmetical equation. There's a difference between them. We are going to apply the equations properties to solve equations. And of course, we're going to determine the solution of equations. So at the end, this is like what we want to do in this first part, okay? Oh, yes. Good morning, Karen. I already checked yourself in the assistance. Okay, so that way I think we can continue. So an equation, an equation. What is an equation? Ideas. What is an equation? Let's start there. What is an equation?
I think an equation is when you need to find the value of for example, in this case, in the example you have there, the
Uh-huh.
value of x.
Okay. It could be like one way. It's like the way to find a no. I don't know. Maybe like
Yes,
that.
yes, yes.
Okay. This probably will be one of those ideas. So try right now to like write four ideas. Remember, we're gonna work with the Jamboard too. Then I will ask you to translate those ideas to the Jamboard. I think we can do it right now. I think will be better.
Can you write mine, Nick? I don't have the computer and I can't use Jamboard on my phone. Please.
Okay. If you dictate to me again, what is it? It's we are at page number 5, where it says equations. What is your idea?
I said that I think that the equation is like to find the unknown of like for this, for example, the x in the example you have there, to
Uh,
find the value of x.
okay, I translate what you say as you say. It's
Okay.
find and unknown a value of x.
Mhm.
Okay. Here is Stephanie 1.
Yes.
Okay. Okay, nice. I'm watching somebody already share one idea too. It's a statement made of two. Okay. I couldn't see who's the one who wrote that definition. We'll appreciate if you share your name and your number list. It's so important. So we have a space over
It
here.
was me, Cynthia. Let me, I'm trying to edit.
Okay, please. Oh, there is Mercedes. So good. Good. I think that everybody's here. That's so good. So I need, did you have like these four um Okay, yes, I got it. I got it with the thing of the Jamboard. Look, one advantage of the Jamboard is that doesn't consume any internet. Okay, so that's why I ask you to have like two devices. I know that sometimes so hard to have those two devices at the same time. We don't have like maybe the money to check it, but I think that we can try it right because today the class is more participation than myself. Okay, so we're gonna do it very quickly. Here I have two ideas, well, three with the one Stephanie gave us. There you have another one. It's a mathematical question or problem that needs to be solved. It's a mathematical statement that shows two expressions. That's why Marcela say a statement that made of two expressions so similar they are related. A declaration. Wow, wow, that's a strong word.
Licenciado, disculpe,
Hello.
¿puede enviar el link de Jamboard de nuevo, por favor? Que no lo pude abrir en el teléfono, entonces ya encendí la compu, por favor. Si lo...
Okay. There he is in the chat. If you see it in the chat of this meeting, right? And if you're in the cell phone, I can send it to the chat of the fundamental class group WhatsApp. There he is. Jamboard link if you need it. And well, let's conclude this. Okay, we don't gonna specify a lot. It's just that I really appreciate your participations a lot, and because it's part of the class. Okay, remember participation points. So there you have a declaration by the symbol equal. Mhm. That shows the equivalence, I think, of two values. I can see this one of Andrea Nicole. It's the process of equations one with of equating one thing with another one. Okay, that's so interesting. So I think it will be okay if we continue fulfilling over there. Just remember to leave your name and the number list, please. So important. That way, a moment to check participation points. I will be checking everything, so we may continue here with the idea of equations. Well, when we work with equations, true. Normally in mathematics, we call those like statements. Okay, like the last class, we wrote some statements for phrases, like the half of the age of my dad is the half of my age plus two, right? It was one of the statements that at the end doesn't work, but at the end has a representation in mathematics. Okay, so an equation is a statement that two expressions are equal. Wow, not too much complication. That's from Khan Academy. Another one, two mathematical sentences or two mathematic sentences that have the same value or represent the same. This is something important. In mathematics, we can represent one thing in different ways. For example, can you tell me two ways to represent the number 6? How can I represent the number 6 in two different ways?
3 plus 3, 2 plus 4.
3 plus 3, 2 plus 4, 3 times 2, 12 divided by 2. So you have many ways to write the same number. I mean, at the end, it's not that you go maybe to a supermarket and you ask for something which price is 20 plus 60, right? Of 80 lempiras. No, you say 80 and that's it. But at the end, we have different ways to represent amounts. And essentially, this is what the equations are about. So you're right. And I like that definition. That's very strong, honestly, because the word declaration in mathematics is related with other thing. So I don't know if it's that you find it like that or if you think it's like this because you wrote it like that. Anna,
Me,
a declaration. You found it like this or you wrote it like this?
I
Declaration.
wrote it like that, but
Okay, it's in mathematics, declaration, it's a very strong word.
okay, so it could be a statement,
No, leave it like that. It's your definition. I'm not saying that you erase it, right? That's why it calls my attention. You know, if you get it from somewhere, but if what you think is, let me tell you that when we say declaration in mathematics, it's about create like a new property. Okay, so I'm gonna declarate, for example, suppose that that you will know, or that you discover a new way to get the calculus of the amount of sugar in your blood. So I'm gonna declarate this. It's essentially when mathematicians use that word. It's
Yes.
okay, it's a very huge word, like I say. So here we have an example, and it's true. The one example that Stephanie was saying, focusing the one of the right, it's related with like the kind of equations we see. But let me tell you that we have numerical equations too. Way to represent numbers in different ways. As an example, 4 plus 5 and 6 plus 3 represent the same number. And if you see, they are totally different. The numbers are totally different. Same over here. Here you have 2 times an addition, and 2 times 7, which is the result of that addition at the end, yes, are ways to represent the same. So we have numerical statements and we have algebraic statements, or a mixture of both of these ones. And I mean, later on, we will see expressions like x equals 2 plus y, for example, which at the end create that equation of variable or of unknowns in order to find another unknown. One of the famous properties that I think you should investigate and add in the forum of this weekend, and it is like a squared plus b squared equals 2c squared, the famous Pythagorean theorem. So here I'm not working numbers, I'm just working letters, I'm just working algebraic expressions. True, it's like this. And this is what the mathematics is about. And check this out. What happened with this one is that we can modify it and convert it or understand it in different ways. Why? Because at the end, one equation works with some properties, and those properties let us understand this one as well. And what properties are these ones? Well, I'm gonna list here the basic properties because we're gonna work the first topic of the algebra related with equations. I'm talking about these. I'm talking about the linear equations. Okay, so we may focus in this one, the linear equations. You should copy it over there. Of course, we're gonna study a little bit of other kind of equations that exist or that you maybe can do. And of course, we already study one kind of equation. What kind of equations did we study in the last classes? Do you remember? Because we already solved something of equations. I think we already like use some of these properties too.
The reflexive property.
Okay. Well, the reflexive property is just like to show that something's equal to itself. I'm asking like for the kind of equations that maybe we already studied.
I think that the symmetric property.
Okay. Yeah, I mean, those properties are already there. My question is, what type of equations we have been solving in the class? Because we already solved some equations. Don't say that no. Maybe you didn't even know they are equations, but you solved it. And especially with story problems, and especially with one little quiz you did the last weekend. Or during the week, I think.
Exponential.
Exponential equations, are you sure?
Or the proportion.
That one of proportions. When we create proportions, we practically create one equation. If 7 is to 10, then 14 is to, well, I don't know, you create an equation and a statement that relates two amounts that maybe looks different but represent the same with the equal symbol. Essentially, that's what we did with the topic of proportions. It is so simple, okay? So let's talk about these basic properties that will help us to define then the way to understand how to solve equations. Because at the end, like I said, we're gonna focus in variable expressions, in algebraic expressions, to understand the topic of equations. So the reflexive property tells you that one thing's equal itself, okay? One thing's equal itself. And here comes a little tricky. Suppose that I have 2x plus 3 equals y. then I can say that y is equal to x plus 4, just to say something. If y is equal to y by the reflexive property, then I can compare those things, the 2x plus 3 and the x plus 4, which is a technique that we will use later at moment to solve equations in a different way. So those techniques looks like simple or pretty obvious things, and yeah, at the end they are like this, but are useful at the same time, because with this one we may conclude some other properties or some other uses of these properties. Okay, I mean, from one property you can make some other, you can declare some other properties. That's the interesting part of mathematics. Of course, some of these ones already exist. With the symmetric property, is the same as you compare this amount with the other one, or y being equal to 2x plus 3. It doesn't affect the order. I mean, you can say that 2 plus 7 is 9, or that 9 is the same as 2 plus 7. That's what these symmetric properties say. And the last one is the transitive. The transitive property tells you something about the relationship you may do with variable expressions. And these three properties together can help you to solve situations like this one. This is a system of linear equations, which is then a topic we're going to study. And for example, if I know that 2x plus 3 is equal y, and then I know that y is equal to x plus 4, what can I do according with transitive property? Here I have like the if 2x plus 3 equals y, and y is equal to x plus 4, then let's see how this logic's working. Sorry.
2x plus 3 equals x plus 4.
You're right. 2x plus 3 equals x plus 4. And that's what the transitive property tells us. Okay, here's a little activity. And if you want to participate, just please raise your hand. We'll give you the word. What I need that you do is like identify what property works in here. For example, we're going to identify with the letter R, the reflexive property, with letter S, the symmetric property, and with letter T, that transitive property. So what about the first one? Is it R, S, or T? Here you have the exercise. It's like 2x plus 8 equals m. Is it R, S, or T? It's one of this ones. So which one?
The reflexive.
It's the reflexive. Is it?
Symmetric.
Oh, so y is reflexive. And then y is symmetric. The reflexive property says that one thing equals to itself.
Yes, it's true.
The symmetric said that when two expressions maybe don't look like the same, you can write it in any order, and at the end they stay like working the equation. The transitive property is the comparison of the other two. Essentially, it's kind of like that. And the transitive property tells you that when two equations works like with one element in common, then you can compare those amounts. Essentially, this is what this property is about. I mean, I have the letter m is the same as 2x plus 8, but then I have the letter m is the same as x plus 17. So practically, if I say by the reflexive property that m is equal m, and then by the other property that I can switch the things or maybe substitute the things, and I can work with the expression that represent m, I mean 2x plus 8, or the expression that represent m, which is x plus 17, practically I'm using the transitive property, right? That's what transitive means. When you have two expressions compare and two conditions working together, then you can make one conclusion with those things. That's what the equation is about. I think the other two are very easy to identify. For example, 2x minus 5 equal to x minus 5.
That one is
Reflexive.
reflexive.
It's the reflexive. And the last one, so will be the symmetric one, because you're saying 20 equals x or x equals 20. So we can just rewrite it like this, okay, by these properties. I'm saying because later when we solve exercises with equations, you may see situations like this one. Okay, so here we have the first three basic equation properties we may use um, in the study of the equations that we will do during this day. Here we go with another properties that will help us to solve equations. So remember that one equation is a statement that uses the equal symbol. Then we have inequalities, and I think we already studied a little bit of inequalities. So if you understand how to work with equation, work with inequalities is almost the same, just that instead of work with the equal, you may work with the greater than, or greater than or equal to, or the less than, or less than or equal to. Okay, so here we have the first property of equation, and it's the addition property. Well, those goes together. The addition and subtraction property practically works the same way. If you add something to one side of one equation, then you have to add the same at the other side of the equation, because that way will be the only way to have this equation working as well. Remember, the equation is the equal, so it means that those things must stay the same every time. What about the subtraction? Well, same idea, just that instead of add something, you have to subtract. So if I subtract something in one side, I have to subtract the same in the other one. That's what the equations are about, like to stay equal every moment. Because if I subtract something from one side, well, I think that we break something we're gonna call balance later. What happened with multiplication property and division property? Well, with multiplication property, we have to multiply. Instead of add or subtract, we have to multiply. Being careful in with something. If I multiply something here, it had to be the same at the other side, and especially with the division. There is a little condition, and that is not multiply by zero, even not multiply by, sorry, not divide by zero. So we have this like little condition that if we will multiply to keep the balance, we should not work m equals 0, okay? Or if we divide by something to keep the balance, we cannot divide by 0. Those are little details, and that happens with multiplication and division only because, well, in addition and in subtraction, we can say that 2, we cannot use 0 like to add or subtract because it doesn't make any change. But because it doesn't make any change, no problem. What happened when you multiply something by 0?
It's 0.
Plus 0.
It becomes 0. Nice, Tracy. Nice, Cynthia. You're right. What happened when you divide something by 0?
It's still 0.
Equals 0.
Who tells you that it's equal 0? Try one division by 0 in your calculator right now or in your notebook. I don't know. Try one division by 0.
It's not possible.
Okay, it's impossible. I think in one class we say it, right? It's impossible to divide by 0. Yes, I remember that when I was studying with you the world of the real numbers. Okay, so be careful. Be careful. Again, I'm gonna say this every time I can. Mathematics about those details. It's impossible to divide by 0. It's possible to multiply by 0, but divide by 0. And yesterday I was wondering to hear the answer of Siri, but your Siri, your male Siri it's like very okay. It's a myth because the woman gives a very good explanation. I don't know if there's a difference between this one. Okay, so at the end, we can summarize all these properties. I mean, the one of addition, subtraction, multiplication, and division, just like keep the balance of an equation. And essentially, when you work a balance, I think that everybody here have been watching a balance before, is that if you have like two amount of things here, and you take out one amount over there, you have to take the same amount over there to establish or to keep that balance working as well. So it's what we will use in order to solve equations. Okay, in order to solve equations, we may use this technique that is called keep the balance, which consists into apply those properties, addition, subtraction, multiplication, division, in order to isolate a variable. Okay, so let's see how this work. Those are like the theory we want to use in order to understand how they work. For example, here, we can like apply those equation properties and see what happened. If I have 6 plus 3 equals 9, applying the addition property, just to show you something. If I add 7 this side, then I have to add 7 the other side to make this balance working as well. Because then I think we're going to have the same result this side as the other one. You have 6 plus 3 plus 7, which will be 16, and then you have 9 plus 7, which will be 16 too. So this stays the same. And this is something we always must be sure that this equation will stay the same. What happens if I have 6 plus 3 equals 9, but instead of add, I subtract? If I subtract 3, for example,
The answer will not coincide. It won't be the same.
it will be the same. But if you see here, something interesting is happening. Something
They
interesting.
cancel each other out.
Excellent. So practically we're saying that 6 is the same as you have. Well, yeah, 6 is equal to 6, it's true. But by the reflexive property, we can say that too, because at the end, those things represent the 6. That's the way to understand this one. We have different ways to understand a number, like I told you right at the beginning. And for example, if here I have 6 equals 9 minus 3, and I have this one that 2 times 3 is equal to 6, by the transitive property, what can I say? By transitive property, what can I say? No idea?
2 times 3 equals 9 minus 3.
Okay, essentially this, that 2 times 3, one operation that gave us 6 is the same as 9 minus 3. How a multiplication the same as a subtraction? Okay, this is the world of the equations, and we may do things like this. Of course, right now I'm just playing, right? Like asking you what happened if. But at the end, those have a logic to exist, and they have a sense to work like this one, and is solve an equation. Right now I'm working numerical equation, and that's why I can play with them however I want. Okay, and yeah, in those exercises that we will try right now about equations, those properties will help us a lot. So check this out. When we work with equations, we normally expect to get one solution. And yes, it's the unknown Stephanie was saying at the moment I asked you to make like the definition of this one. How can you solve one equation? Here you have this equation. 2x minus 6 equals 18. Did anyone remember how to solve those equations? Those are called like the two steps equations. I don't know if somebody knows how to, or remember how to solve these ones.
You isolate the x.
And how? Yeah, because at the end, it's about that. Isolate the x. It's
You
true.
pass the 6 that is negative, adding it to the other side.
And why add it
Because when
to
you
the other
pass
side?
negative to one other side of the equal sign, it changes its polarity from negative to positive.
Why?
Because of the property, but I don't remember the property.
Okay. Honestly, this is like more didactical thing than a mathematical thing, to be honest. Because this is not the property, essentially. Let me tell you that it's not wrong what you're saying. No, it's how I teach too when I work with equations, because it's the easiest way. And I let my students understand that if here you have one operation and the other side will change it to the opposite. Of course, it's not that I pass the 6 to the other side to multiply or to divide. No, it passes to add. Because here is subtracting, so when I make a move, it has to change. It's an easy way students understand, and it's true, it's how we learn it. But honestly, this is not the property that works over here. Well, what we want to do, like you say, is isolate the variable expression, in this case, x. And in order to do it, we will like try to eliminate the things around it. Okay? So what we should do in order to solve it, like you say, pass things to the other side. So I think you're not gonna have problems at the moment to solve this one. But let me tell you that the real property that's working here, the mathematical property that's working here, 2x minus 6 equals 18. It's essentially next one. If I'm looking for the way to isolate the variable x, I'm gonna try to eliminate those things around it. For example, the 6. How can I eliminate the 6? Here's a little example. Here's a little example. For example, I eliminate the 3. The 3 was adding, so then I subtract 3. I do the opposite. In this case, the 6 is subtracting, so what can I do?
Él ya tiene preparado
Pass
todo
it
eso.
to Aaron.
Yeah, and it will not be passed to the other side. It will not be passed to the other side, to be honest.
It will be adding.
It will be add 6 in both sides. Now you see how the properties work, right? And yeah, normally this is the way to solve it mathematically, right? But of course, nobody's going to be doing that. Now, is it clear why in the other side this 6 is adding?
Yes.
Okay, that's the why. I think that's what this class is about. So then you're going to have 2x equals 2, 6 plus 18 will be 24. And of course, then you have to do something with this expression in order to eliminate that 2x. And I will do a little question first. But I think that we can try to see it here. So eliminating the 6 by adding 6 in both sides will be the way to do it. Of course, I'm adding this property. And how can I eliminate the 2? Dividing 2 in the two sides. Because what is the 2 doing to the x? We said yesterday. It's the coefficient of the x. What the 2 is doing to the x? Do you remember? What does the coefficient do to the variable? It's multiplying it. So if it's multiplying it, what we have to do in order to eliminate a multiplication is divide. I mean, if I get the double of something, to get that something, I need to know the half of that one. Does it have a sense to you?
Yeah, you have to divide 24 to 2.
Exactly. And 2x to 2.
Yes.
You got now, how is the idea of keep the balance? And yes, this is honestly the way we have to work with. Now, here comes a little question, because the exercise is solved. Of course, you can check if 2 times the 12 minus 6 really gives you 18, and it really gives you 18, okay? Because you can check at the end, this is that solution of the equation, like you were saying. Now, is it always that we have one solution? No.
Mr. Bird, I think it's easier to just isolate for x, right? For me,
And
it's
that's what we did.
yeah, but I think this one is more complicated.
Well, honestly, it's more complicated, but it's what helped us to understand or gave us the fundamentals or the basis, I think, the basis of the process we normally use, which is pass the 6 to the other side. Well, the negative 6 to the other side, right? Which is the way we learn. Of course, sometimes we have to, how can I say desaprender? Dislearn? Dislearn is not a word that exists. But we have to do
Unlearn.
Unlearn, sorry, yes, that's the right way, sorry. Unlearn what you know to learn that things, how really they are, honestly. For example, I don't know if one student ever asked you, like, why when you move the 6 to the other side turns positive? Because we learn these like laws. Normally what we learn, or what we do with what we learn is like we live it like this and that's it. For example, in mathematics, we don't try to modify the things. And mathematics is very open. It's very open. We can solve these other ways. It's so interesting. For example, there is a guessing and checking method that let you get the answer to. That's so hard sometimes, right? And sometimes the direct way is better. Sometimes we focus in just one way when there's not just one way. Don't know if well, I think that you haven't teaching this topic, but if you have the chance or the experience, now you have the right properties that let you explain why when you move the negative 6 to the other side becomes positive. That's the why. Because essentially I'm adding 6 in both sides. So if I add 6 and I subtract 6, practically I'm eliminating the 6. But if you see it have an effect on the exercise, so that's the why. Now, my question is, and I think you should know that, why we don't focus in the number 2 first? Why we focus in the number 6? Because are the bases. I want to that you understand the
Because
bases.
we need to isolate all the numbers around the x, right?
Aha. So why don't we start with the 2?
Because we start eliminating from out to
Yeah.
in.
Mm-hmm. So that's the why, really. That's only the only reason we have from out to in. It's a good way to learn. It's true. It's a good way.
Or maybe you start first with the addition, then you follow subtraction, then the multiplication. It's like the steps that you gave us at the beginning, how the properties began.
Uh-huh. Kind of. Kind of. Here comes a little observation then. Here comes a little observation then. Let me show it. What happened if I have 2 times 12 minus 6? Will you solve first the subtraction or the multiplication?
In that
The
case, I think it's all the
multiplication.
multiplication.
The multiplication, right? So it will be 24. And then we have 24 minus 6, which gave us 18. Now, listen. Essentially, we have the result of the operation that we don't know how it works. So we have to go backwards. And I think we normally teach the topic of order of operations with this kind of word. Don't know if you ever teach with this one before, PEMDAS, or hear about this one before.
Yes.
In the one you start working parentheses, then you work exponents, then you work the multiplications and division. Okay, listen, those goes together. It's not that first multiply.
Those are the PEMDAS, something like that, right?
That's PEMDAS. If you see PEMDAS, PEMDAS. And then we go with the additions and subtractions depending who's first. Okay, but it will sound so weird. But because right now I'm doing the opposite. I'm not multiplying, dividing first. I'm not adding, subtracting first. I'm guessing how this expression was. I will go the other way. I mean, I will go the opposite way as this one. So essentially, I will have sadly like this. I'm not include parentheses here. So first you have to focus into pass to the other side additions and subtractions if you want to see it like that. Then you have to focus into pass to the other side multiplications and divisions to finally focus in exponents. Essentially, it's go the other way, right? And this maybe will be the other way to understand like why we have to move the 6 to the other side first. It's everything related with basic rules of mathematics. Of course, if we don't learn, if we don't know the basics, how can we go to the interesting part? Okay, so I think we have a very good justification of everything that we have been learning until today. I mean, it's not we learn it because yes, and that's it. No, there is a reason. And this is what this class is about. Okay, here I have 3 exercises that I propose in the Jamboard, and I will appreciate if you try to solve it. Okay, that is on page, oh my God, you already solved it. That is on page number 6 of the Jamboard, and that's so good. And yeah, that's what I recommend, that I will recommend to you to use the text box option. Just that I couldn't see who tried this ones. Let's see, here was Maria Daisy. And yeah, we can try it over here too. The same procedure as you show us. Is seat 8 the solution? It's 3 times 8 minus 6 equals 18. It's kind of like the exercise we try right now. What about the other one? Okay, nice. You're using like the idea of keep the balance. You're gonna share a picture here, I think so. That's so good. That's so good. It'll help you to make it bigger. There he is. Don't worry, I already helped you to make it bigger. And you can paste it over there. Just don't forget to write your name right. Oh, Jerlin. Okay, I'm gonna write it here, very small. There is an option that let you write it too with the like a post-it. I'm gonna give you a pink posting. Geraldine, what is the number? What is your number, Liz? Geraldine, is it like the number 20? No, it's like 18, right? Don't remember. What is the number? Your number, Liz, Geraldine? 19. Okay, 19. Okay. So here we have it, 19. And here is like a way to do it too. We have another picture over there. That's so good. Amazing, amazing. So I think we have the three answers over there. Of course, we can check, and to be sure about it, this is the best thing we may do. And I think at moment to check equations, we must be sure they really makes the expression works, that you must show that they really make that balance, have the same value, or makes the same value. Of course, some ideas about the balance are working in other areas like wow, what's happening over there? Some ideas are working in other areas like chemistry, for example. In chemistry, you balance some reactives and situations like this one. So I think we are very good solving equations. You're very good solving equations. Excellent, excellent. There you have it. And even with the checking, so good, Eunice. I think it is exercise C, right? That's so good to hear, Anna. Very good. You conclude the answer as your classmate Maria Daisy did it. So good. So good, so good. Just that you use the idea of pass to the other side, right? Yeah, no problem. You're free to use the method you wanted. So good, Miss Cynthia, too. You did it so good here. So we're going to continue trying some other ideas, some other exercises then, as we have it here, right? But give me a second to be here, because we're going to see what happened with one specific case. I think we can solve the letter A, no problem. But what about the B? What about the C? What about the D? They require something different. So we may see what is this topic about, okay? So very good, very good. You already know how to solve equations, I think so. And you got the answers. For the first one, 8. For the second one, 7. And for the last one is 5. Okay. And here we go with one more observation. So let's go back to the PowerPoint presentation. Here we have it. Is it possible to have more than one variable expression in the equation? Yes. Here is a little example. And how can we solve a situation like this one? Do you know how to solve it? Because as we keep the balance with numbers, we should keep the balance with variables too. Okay, Xiomara, I hear you.
Okay, on this case, you will pass the 3 to the other side. So it will be 5x minus 3. And then the 7, you'll pass it to the other side. So it will be, okay, yes, minus 19 plus 7.
And why like that?
Because we have to put like the same terms together. For example, the numbers that have the variables, and on the other side, the numbers that don't have a variable.
Okay, so variables with variables, numbers with numbers.
Yes.
Same term, you say. There is an equivalent word we used yesterday to talk about those expressions.
Like terms.
Like terms. So we must use the like terms with the like terms and work it together. I mean, there's no way to get that subtraction of 3 times that value of x that I don't know, and 19. And there is no way that I get the solution of this one too. So that's why you should look for the way to like put those things together. Essentially, what I do is subtract 3x in this side, so then I subtract 3x in the other one, those like cancel each other. And then I add 7 in this side, so then I have to add 7 at the other one. Essentially is like this. Keeping the balance property, we can conclude the answer of that one, or translating to the other side, which is the technique I think and I see is the one that you prefer to use. But of course, we must understand from where those properties come from. So to eliminate this, what we have to do is subtract variable or variable expression 3x in both of the sides. Of course, the way to do it is subtracting in both of the sides. And then we're going to have a situation like the other exercise we try, right? Like the first exercise we made. So I think we are ready to solve this one. How can we solve it? In a very quickly way. First of all, if I add 7 this side, then I have to add 7 the other one. My new expression becomes like 2x equals to -12. Now that I'm sure about this one, what I have to do is divide this side by what number? And if I divide by a number there, then I have to divide by the same number over here. It's by 2, right? Divide by 2 both sides, or by the translating technique you prefer to use. If you pass the 2 to the other side, in the other side becomes to divide. The same idea. So at the end, x will be -6 as we have it here. It's in your hands to check it, because at the end, those kind of exercises are about this. Checking those solutions to be sure you really conclude the answer of these exercises. Okay, I think you're clear solving equations. So any question about how to solve equations? Any question about it? That maybe it's not clear to you? No?
You can ask again, like,
If there's any question about the solution of one equation? No?
no.
No?
But the way how I was solving the equation, it's okay as well.
Like,
Or do you wonder like how you
No,
are doing
no,
it?
no, look, I'm not, I want that you solve it, honestly. How you solve is your decision, okay? But for example, now we are
Yes.
clear why when we move the 7 to the other side, it becomes positive. Okay? Or why when we move the 2 that's multiplying, the other side must be dividing. At the end is because of these simple techniques. So you're free to use the method you wanted, okay?
Okay.
I'm not going to ask you to solve it in a specific way. I'm just showing you that how the mathematics works. That's my job. Okay, so now we're clear. I think that when we check a solution, what we should do every time with equations is be sure that it really makes the expression works the exact value, okay? As at the beginning, I show you an amount of many different ways to represent a number. Well, I ask you like, and show you like 2 or 3 ways to represent a number. For example, the number 6, you told me 4 plus 2, you told me 2 times 3, you told me 5 plus 1, many different ways. I told you 12 divided by 2, you can tell me 18 divided by 3, it's true, but at the end, we must be sure that those expressions really makes the equation works, okay? So, I'm gonna ask you to focus in these consequences of equations. Because right now, maybe we're clear with the topic and we can teach the topic. We can let understand the students what will happen if, okay, but we may like consider the consequences. First of all, many topics are related with mathematics equations. The hardest level that those equations can reach, it's related with differential equations, which is a topic of higher level. And it's like try to model real situations with variable expressions. Have you ever seen one real situation modeled with a simple equation? Because there is one so simple. And I think we already talked about this one too, the last weekend. No idea? What about the speed? There is one simple way to get the speed of something. For example, those who likes to exercise, I don't remember who told me that practice sports.
Me, Marcela.
It was Marcela, right? It was
Yes.
Marcela. Yes, you told me like spinning, right? That's what you say?
Spinning, Zumba.
Wow. So in the spinning, how can you get the speed? How can you measure the speed?
For
I-
minutes. You have to okay, when you're on the bicycle, you have to make your legs turn a certain amount of times in per minute.
And distance, right? Measure like the distance and the time.
Yes.
Okay, yes, it's like that. Ana Maria?
No, yes, I was going to say that the distance and the time, and I mean, that way you can find the speed.
Excellent. That's what the speed is about. And if you see, we compare two simple amount, right? Yeah, we make a ratio, the ratio of the distance and the time. And at the end, this is a mathematical expression that let us understand or measure something. At the end, the main objective of mathematics is measure the world, measure everything inside of it. Of course, some people things that are exist, some things that cannot receive a number. For example, the beautifulness. Yeah, it's so hard because it's very relative, you're gonna say, right? Who's maybe handsome for you, maybe will be so ugly for someone else. I don't know. At the end, it's true, but there is like one way, and there are many things that keep in mind. Sorry, that some people keep in mind in order to find the beautifulness number. So weird. And there is one situation related with this. As an example, what number that looks or works in many buildings, for example, which is a proportion at the end that works with numbers of one sequence that I told you. For example, 3 and 5 made that proportion. Other example of this one is 5 and 8, 8 and 13. Those proportions at the end will try to get that number. This is the golden number, okay? And you can get an approach of this one with 8 over 13, 5 over 8, 3 over 5. At the end, numbers are useful to measure things. And at the end, equations can help us to model those situations to represent these in different kind of ways. For example, if I run right now and you take my time, maybe I'm very slow. But if we take Marcela's spinning time, I think it will be very fast. Okay? And what helps us to understand who's faster than the other one is a simple number. Okay, so like I say, it works to model situations like phrases or sentences. Last class, we tried to convert one phrase into an algebraic expression. So then we can make it into an equation. It's like the idea. In algebra and in geometry, we're going to work with equations a lot, with properties. At the end, formulas are kind of equations, are literal equations. At the end, it's true, they work just with variables, but they are hiding the idea of that at the end you can solve something. And it's like the main objective of equations too, solve something, like you say. So what we want to do is simplify a problem into a mathematical sentence, which is something we're going to try to do with some of the exercise that I prepared to you in the Jamboard. So let's move to the Jamboard again. And I think we're going to be ready to solve some kind of equations, especially the first two we have over there. Just give me a second, that is loading. Here it is. I think somebody already, yeah, so good. You already solved the first two, right? Cynthia, you got the answer 8. Because you have, and then you pass that 2 to divide. So the answer is 8. Did you check it? Because I think Marcela is saying one answer, Maria Daisy is saying another answer. I don't know if you already check it. Do you know how to solve quadratic equations? If you know that, that's so good. Let's see here, Tracy, in this exercise, what you did is like pass the 2x, and you have the same answer, right? Ah, okay, you saw something over there. Cynthia, it is okay. It is okay. It is okay. That's all good. Okay, I'm gonna help you to make this one bigger. I don't know who's sharing this one. Oh, there he is, Jerlin. That's all good. You leave it in the picture. But I'm missing those other two, all right? I think we have enough for this first one. That's all good. Here we have another picture, and this is this Jerlin's picture too. Yes, it's the same as Jerlin. Good. It's the same exercise proposed. I mean, the same participation. That's all good, Jerlin. Here we have the one of Marcela. Here we have the one of Tracy, and it is okay. It is okay. Okay. Yes, I think you got it. This is how we can solve these exercises. This is Maria's Daisy. This is the one. And yes, I think it is done. So the answer changes, right? The answer changes, Cynthia, because I think you.
Yes, I got it. Thank you. Sorry. Yes.
This one, you should keep the balance, right? But you did
Yes.
it. But you didn't do it.
Yeah.
Okay, because
I got it.
you add 7 and you add 7, so then you make 14 at
Yes,
7, but
thank
you
you.
add 7 at the other side too. Okay, we can look at those details. That's so good. That's so
I'm
good.
trying. I'm
we are
trying.
learning. It's part of the process. But it's so simple. Equations are simple. Now, how can we solve the other ones? If you see they have something different, what is the different thing they have?
The other one has an exponent.
The other one has an exponent. It's true. What about the first one? The first one doesn't have an exponent?
But it has different variables.
Okay. Those variables are practically the same, just that they are behaving different.
Yes.
Because one's working like x to the second power, the other one is working like x to the power of 1. Let me tell you something important. Just a little question. In letter A, what about the algebraic expression 2x plus 7? What is the degree of 2x plus 7? What is the degree of that binomial? 2x plus 7. Just focus in the 2x plus 7. What is the degree?
7.
No, 7 will be the independent term. The degree.
Linear.
It's 1, okay? The degree, it's 1, and that's why it received the name of linear binomial, right? When the degree is 1, and here comes like the fundamental theorem of algebra, and when the degree is 1, it means that you expect to have one solution. When the degree is 2, like the exercise you're trying over there with, oh my God, so you have an idea about how to solve this one. So good. So good. That's so good. Yeah, it's what we will try right now. When you have an exercise like this one, that x is to the second power, according to the fundamental theorem of algebra, you expect to have 2 solutions. And it is so interesting. And this is what we will study right now. So if you remember so good how they work, there is a formula that let us get this exercise answered very quickly, like Nicole is proposing over there by the factorization. That's so good. Yes, it's true. That's the way to get it. So let's see now how to study those kind of equations that you are telling me, that you're showing me you already know. Because at the end, the equations doesn't work linearly always, okay? The equation works in different ways. So let's see how the equation can work, because it's true. Even you can have an equation with x to the power of 3. What does x to the power of 3 means then? What will it means if you have x to the power of 3 in one equation? that you expect to have 3 solutions. X to the power of 4. Okay. Honestly, it's not that you're gonna have exactly 3 solutions, right? You can have like 3 solutions, 2 solutions, 1 solution, or maybe it doesn't have solution, which is something that happens even with linear functions. Linear functions or linear equations, I mean. Linear equations can give us 1 solution or non-solution, but there is one kind of equation that gave us many solutions. Okay. So focus in this second part, because now we're going to talk about the type of equations that exist. Not all of them, to be honest, but the ones that you should know in order to teach in these elementary years, right? So let's see this first part of the topic. And we want to describe the type of equation, just describe it. But I already gave you one part, one element that is so important. The degree of the equation, we can say it like that. At the end, equations doesn't have degree. The algebraic expression we see in the equation has the degree, but at the end, let us understand this idea. Can help us to see the amount of solutions we expect to get. What we'll normally do when we work one equation is try to convert it into a linear equations, like the ones we solved at the beginning, the ones that require you pass to the other side. This is essentially the topic equation, what the topic of equation is about, okay? And at the end, it's simple like that, okay? It's just convert the things into, convert the things into linear equations. That's what we will try. So we're going to solve equations by using these principles of linear equations. So here we go. Type of equations. The equations we normally describe depends on the amount of the variables in the exponent. Honestly, more the exponent than the variables. The linear equations normally work with one variable. The quadratic equations work with one variable, but one of these variables should have exponent 2. That's why they receive the name of quadratic. We named it this the last class. Cubic equation. How do you think will be a cubic equation? How will be a cubic equation? Or what will make an equation behave like cubic? No idea? In linear equation, we see, and one example like 2x plus 7 equals 9, like the exercise you solve over there. It's a linear equation. We expect to get one solution. Quadratic equation, okay, x squared plus or minus 7x minus 8 equals 0, for example. You have equations with one variable, but that variable is to the second power. So what makes a cubic equation be a cubic equation? Is the x to the power of 3 is practically the degree. This x to the power of 3, this 3, is telling you that you expect to have 3 solutions, or that you will have 3 possible. The word possible in mathematics is so important. 3 possible solutions. Okay. So in general, if we have a polynomial equation, what we should see is the degree that it has. And depending this, we will expect an amount of solutions, not the solutions, right? I mean, an amount of solutions from that equation. It means that in one linear equation, I cannot get 2 solutions. In one quadratic equations, I can get 2 solutions, like the most amount of solutions I expect to have from this one. Okay. So here comes one important topic, and it is that it's possible to mix equations then, because we can create another kind of situation with 2 different equations. When we work 2 equations and 2 variables, for example, or when we work one equation that have 2 variables, it's so hard to solve for one of these ones. Suppose you have next, x plus y equals to 16. Can you tell me the solution of this equation? I mean, at the end, you will conclude a value of x and a value of y. Can you tell me what is the solution of that equation? Is it possible to solve that equation?
Yes, it's possible, but don't we need to know at least one of the values of the letters?
Ah, okay. Because right now we're not clear, like if truly 14 for x and 2 for y will make 16. If maybe that's the solution we wanted. Or maybe the opposite, x equals 2, y equals 14 will make 16. Probably this is the combination. Or maybe x is 13 and y is 3. If you see, we can make many combinations as we want. And the combinations we can do are infinite. And this is not acceptable for these kind of exercises. So one equation working this way will require, and I think you should copy next, will require another equation, okay? Another equation involving the same variables, okay? Or maybe one of those variables. If I say now x is equal 10, then you can solve for y very quickly. And this is the other topic we want to study related with equations. Now that we're clear like how the equations works, of course, we're going to see how to solve quadratic equations, which are the two exercises over there, but I saw some of you solve it, so have an idea of how they work. So we create something that is called systems of equations. In this case, that I'm working linear equations, I create a system of linear equations with n variables. In economy, for example, one of the contexts that I really enjoy with the mathematics, there are systems of linear equations with 100 variables in order to analyze how the economy of one country works, for example. It is not too easy to solve one of these exercises, it's true, take years to solve it because it depends on the values of the most sold things in the country, right? For example, in our country, we have the coffee, we have the beans, we have what else? Other of the elements that normally we produce in here. The camarones, I mean the shrimps, and all this stuff will be involved in one system of linear equation to be solved. It's so interesting in order to see how this works. Do not somebody here have some studies of economy and ever seen this application? No. It's so interesting too how the mathematics work in real life. So what we create here is a system of linear equation. Essentially, the systems of linear equation works with two variables and two equations. And those equations contain the two variables. Normally, it's like that. Or sometimes one of the two equations just work with one variable. But at the end, if you have two equations, well, I mean, if you have two variables in one equation, you expect to have another equation to help it to be solved. If you have three variables in one equation, then you expect to have two more equations that will help you to solve the other one. It's the idea. Okay, there are system of nonlinear equations. Here is one example. And why this one is nonlinear equation? Who can tell me why? Why this one that works like x squared plus y squared equal 10 and then y equal to x plus 2? Well, it's nonlinear equation because this equation that I have here, it's a what kind of equation? The x is second power, the y is second power. So we can say that degree of the equation is 2. This is a quadratic equation. And normally those are called like nonlinear equation. But the topic that matter to us right now are the linear equations. So what are the kind of linear equations we may study? We will see. But let me tell you something else too about how mathematics grows in itself. Those topics, the topics of linear equations and the topics of nonlinear equations, let us create new algebraic strategies based on the properties that I told you at the beginning, the symmetric, the reflexive, the transitive, the addition property, the subtraction property, and the multiplication and the division property that will help us to solve these new kind of situations. And of course, sometimes one equation is not enough to solve one problem. Sometimes we need two. Sometimes we need three, depending the model we want to create. Okay, so here we have one simple idea. Linear equations, which normally are degree 1, have one solution. And normally we can get one result. Here's a little example of a weird situation. How can we solve this equation? It's a linear equation. It's true. We have x plus x equals 2x. Well, that's essentially one equivalence because those expressions are the same. Practically, I'm saying that 2x is equal to 2x. What will be the value of x that let us solve this equation? Careful. And this is the situation I told you. It's not that always we can conclude that we have just one solution because the degree of this expression is 1. So we must have one solution. No, we have one possible solution. That's what we have to say. Because sometimes this kind of equation, even if they are linear, quadratic, anyone, can create weird situations like this one that at the end help us or let us conclude the solution like this one, that x can be any number. When this will work, I mean, when the double of a number will be the double of a number. Okay, when you multiply that number times 2, and that is essentially what you are representing in here. Or another way to understand it, how can you get the double of a number? Okay, multiplying it by 2 or adding the number itself. In this case, we can focus in that idea and connecting the first topic we studied with this topic that we are talking right now, we can have one real solution in this kind of equations we work, which are the linear equations. Okay, so the topic of equation is very huge, but the topic of systems of linear equations is very specific because help us to understand the relationship of equations in another way and the properties that I told you in another way. Okay, so here I have some other kind of equations that we work with, and let's see what happened with these ones. For example, 5x minus 6 equals 18. It's something that we can solve very quickly, passing the negative 6 to the other side if you want it like that, or adding 6 in both of the sides. I'm going to respect your decision to work with the translation of terms to the other side. So in this case will be passing to the other side. It passes to add because here is subtracting. So at the end you have 5x equals to 24. Of course, we're going to have a fractional answer, which is a real number at the end. 24 divided by 5 is a real number. You can get the decimal, but it's a real number. So we expect to have one solution from this one, and we get it. How can we solve the other one? Okay, in the other one, I think that we should connect some like terms in order to see what happened with this one. This expression becomes like, let's use another color, becomes like 2x plus 4 equals to 2x, and here we have another like term, the negative 8 and the negative 1, 2x minus 9. Passing variables with variables and numbers with numbers, like you said, we're going to have 2x minus 2x and negative 9 minus 4. What is 2x minus 2x?
They cancel each other out.
Zero.
So practically we have 0 equals to negative 4 and negative 9. They make negative 13. So question to you, is 0
It will
equals
not
to
be
negative
x,
13?
or we do not have any more x.
Exactly. We don't have x. So what we have to look for, I mean, at the end, you're going to have 0 times x, that is 0, because you say it, 0 multiplied by something is 0. And this creates something that is false. So what can we say about that equation?
That is not a
No
linear
idea.
equation.
Well, it's a linear equation because the degree of the expression is 1, but has no solution. Okay?
Okay.
That's what we can say. That there is no solution for this one. This is so important. This is what I want to tell you with the other, with the observation of the topic. That's why we can say if it's a linear equation, we expect to have one possible solution, or possibly we have one solution. If it's exponent 2, okay, we expect to have 2 possible solutions, or possibly we're gonna have 2 solutions. What about the next one? Let's see in the next one, and something similar happens. This is 3x plus 9 equals 2. Okay, let's see what happened when we join the like terms. In this case, we have the 4x and the negative x, which make 3x. And then we have the 7 and the 2, which make 9. Well, what happened with this one? What do you think will happen with this one? Okay, working variables with variables, like you decide to work, and numbers with numbers, like you decide to work. What is 3x minus 3x, and what is 9 minus 9?
0 equals 0.
Okay, now we conclude something that is true. This is true. This is totally true. So what can I say about the solution? I mean, what x value can I work in here? If I have 0, is it 0 the solution? So in this case, we can say that it has no solution, and it is because any value you decide to work for the x, any real number that you decide to work for the x will work. So we can say that this has many solutions. It has many solutions. X can be any real number. And remember, this is the representation for real number. It's true. So at the end, it's like that. X can be any real number, and because we make something that is true. So there is a difference between these 3 situations, and maybe something like that will happen in quadratic equations, in cubic equations, in any of the equations we start. Okay, so I think that we have here like a very clear point of view of the different inconsistencies that normally works in the linear equations or in the equations in general. Okay, so to talk about the way to solve any kind of equation, here we have another way to solve it. In general, polynomial equations. Honestly, this part will be just the theory that I will tell you to keep in mind how to solve it, okay? The remainder theorem and the factor theorem are related with the polynomial division. So we're not gonna focus a lot on this one. The zero product property is one property that I saw you use, and I don't know if you can tell me how to use it, or maybe I will tell you like why it works. And of course, the factorization techniques can help us to solve those expressions that works like x to the power of 3, x to the power of 4, because at the end, the factorization techniques let us convert those x to the power of 4 into like the multiplication of 4 things that are x to the power of 1. Linear equations, I mean. It's so simple. So how can we solve polynomials using the remainder theorem? It is essentially, like I say, focus in make division of polynomials. And question to you, what happened when you divide 2 numbers and the remainder is 0? I think we already know that. What happened when you divide 2 numbers and the remainder is 0? For example, what happened if you have 24 divided by 6? What will be the result?
4.
And what does that 4 means?
That you have 4 equal
Okay.
parts.
Thinking in the division, thinking in what this quotient represent, it's practically representing that 4 times 6 is the same as 24. Essentially, that's what it is, right? So, in order to understand this simple idea, what we have at moment to apply this kind of method, which is the remainder theorem, what we expect to have from a division, no matter if it's a synthetic division, no matter if it's a long division, is remainder 0. Because this will create a situation like that. Why this is so important? Why is so important to rebuild, listen, because that's what we normally do, rebuild or reconstruct this x squared minus 4x minus 21 like the product of x minus 7, which is my quotient, or my result of the division, the remainder is 0, and this x plus 3. Okay, what we normally do is focus in this idea, is the product of those, the x minus 7 and the x plus 3, will make the variable expression you're working over here. So this is practically factorization. Do you know some factorization rules? Do you remember some factorization rules or some factorization facts, for example? Because I saw you were using an interesting way to solve equations, quadratic equations. Very good.
I don't remember. I forgot about that.
So don't worry about it, because at the end are very simple. And honestly, for the exercise that we will try, I will give you like another option too, not the direct option of factorization. But this option of factorization will let us understand how can we convert any exercise into a linear equation. I mean, an equation that you can solve just by passing to the other side, which essentially is the objective of the topic of equations. Okay, here comes another property that will help us at moment to solve any polynomial equation, and it's the zero product property. I saw that you use it so good at moment to solve one of the quadratic equations. For example, if you have the product of two things or two numbers, and you don't know two numbers, you just know that the result of this one is 0. Can you guess one of the numbers? Can you guess one of those numbers?
0.
0, but which one is gonna be 0?
Either one.
Okay, because I don't know which one, I can suppose that either of both will be 0. Essentially, that's what the zero product property tells us. So maybe this number is 5, but the other one must be 0. Or maybe this number is 20 and the other one must be 0. Okay, we don't know. At the end, because we don't know which number is which one, we can look for the way to suppose, right? To make a supposition. And this supposition is acceptable for the zero product property. I mean, when the product of two things is equal 0, we can suppose that. Suppose you have next exercise. Suppose that you have the exercise I showed you, x squared minus 4x minus 21 equals to 0. By the remainder theorem, we discovered that this expression should be written like x plus 3 times x minus 7, which is essentially the same. So we factorize that expression like x plus 3 times x minus 7 equals 0. Then I have the product of two expressions, and this is equal 0. What does it implies? What does it implies? It implies that one of those things is 0. I mean, x plus 3 is 0 or x minus 7 is 0. Which one is 0? I don't know. So by the zero product property, I'm going to suppose that either of those or both are equal 0. And what happened here? Check this out.
X equal minus 3 and x minus 7 positive.
And x will be positive 7. Okay, but if you see what happened with the equation that at the beginning was a quadratic equation, becomes into what?
Linear.
Becomes into two linear equations that right now we solve it just by passing to the other side. So all the topics of equations are related with this. It's so important, these little details. Okay. So here we go, and we have the factorization methods. There are some special product techniques. Here you have a YouTube video of 11 minutes that I will share to you, and you can watch it later about those factorization techniques. Of course, I'm not gonna ask you like to solve a factorization exercises. Maybe I will ask you to try one factorization exercise like the one you saw, like the one you showed me. Sorry, the one you showed me in the Jamboard. So I think you're already like a little bit familiar with factorization methods. I'm gonna share the link in the Jamboard too. Okay, there he is. So this video is so important. Watch it, please. Watch it. And I'm watching you already fulfill the part of the page. Interesting.
Where did you share it?
The Jamboard.
Ah, okay.
There will be in the Jamboard a YouTube video for the factoring techniques. Okay, this is what the video is about. Our factoring techniques. Just watch it. Okay, honestly, I'm not gonna evaluate factoring techniques because I'm not teaching you this one. But there you have the option to explore how those techniques can help us to rewrite one expression like the one I show you right now, like this: x squared minus 4x minus 21, like the product of other simple expression, which at the end makes linear equations. Okay. Here becomes one way to solve any quadratic equation. And honestly, this is something too much important to me. And I think we're gonna try it in one exercise, but I think you already solved it. Don't know what method you use, but at the end, you're able to use the method you wanted. At the end, in these kind of exercises, we want to explore the quadratic formula. How can we solve this kind of exercises? For this type of equations, we're gonna get two solutions. So we may solve it using one formula. I don't know if you ever use or if you remember that famous formula, which is called the quadratic formula or the general form. And it is useful to solve specifically exercises that behave with that x to the second power. Of course, our job will be like identify who's A, B, and C, and then replace, because in a formula, like I was saying, what you do normally is conclude the values that you should replace and then use it. This is like what the topic is about. So how can we solve one quadratic equation? We can apply the factoring method. We can apply the general formula that I want to show you, apply the factoring reminder theorem. So here you have options to solve it. For example, here, I will solve it by using this quadratic formula. X equals to negative b plus or minus the square root of b squared. So this is a formula, right? Minus 4 times a times c. I mean, you can get it over there. You can have it over there and use it when you have any exercise behaving like x squared. What is the general form they have? They have like the form of ax squared plus bx plus c equals to 0, which let us identify in a very quickly way what is a, what is b, and what is c, to then replace this information in our formula. What is a for our exercise? I mean, what is the coefficient of x squared?
1.
1. It's 1. What is the coefficient of the expression with x?
Negative 5.
Negative 5. And finally, what is the constant value here?
6.
Is 6. So we are ready to replace in that formula and get the answer. So that was what is the topic is about, right? Of course, I'm going to evaluate quadratic equations because they are so simple. What you should remember is how to introduce the square root in your calculator. That is simple too. So here we're going to try to solve this equation, and we're going to have the negative sign over there and the b, that is negative 5, plus or minus the square root of the b, that is negative 5 squared. And here comes one recommendation. every time that you replace one value of a in a formula, it's a recommendation, use parentheses, okay? That's the recommendation. For example, I replace the b, as you can see, but I use a parenthesis. I have b squared, but I use a parenthesis for the b. I have the value of a and the value of c, but I use a parenthesis for each one. Why? Because sometimes those signs or those elements of the formula are affecting the values, and it's so important this. So let's see how can we solve that one. At the end, we're gonna have a positive 5, plus or minus. Inside the root, we have the result of negative 5 squared, which is 25, minus 4 times 1 times 6 is 24. And this will be divided by 2 times 1, that is 2. Solving the exercise, the expression inside the root. So we're going to have 5 plus or minus the square root of 1 over 2. So here we have to separate these in two different ways because there's no way to add and subtract at the same time, right? I mean, you cannot solve one operation adding and subtracting. At the end, you will make 0 if you add and subtract. And what we want to do with this exercise is to get the two possible solutions we expect to get from it. So what are the two possible solutions we can get from this one? To do it, first of all, we must check if we can get the square root of 1. Is the square root of 1 an exactly number? What do you think is the square root of 1? Can you get the square root of 1 in one calculator? I think you can.
It's 1.
It have to be 1. Well, there is a little observation with the square roots. Normally the square root, look for a number, multiply itself twice, 2 times, giving you the number inside the root. In this case, 1. Maybe if I ask you, what is the square root of 4?
2.
2, because 2 times 2 is 4. But what about negative 2 and negative 2? Is negative 2 and negative 2 making 4? Negative is negative, is positive. 2 times 2 is 4. So yes, at the end, one square root gave us like 2 results. And well, that's the why we have the plus and the minus over there. And this implies that we may separate this exercise like into the addition of 5 plus that result of the root and the subtraction of 5 and the result of that root. Normally, the radical expression or the calculators gave us the main root, which in this case is the positive one. But that's the why we have over there this plus and minus. It's not that we're adding, subtracting at the same time. No, you add one result and you subtract the other one to conclude the two answers. So then you have to solve 5 plus 1 divided by 2, which will be 3. Then you have to solve 5 minus 1 divided by 2, which will be 4. And this is the way to solve this kind of quadratic equations. Of course, we have other methods like factoring methods. And let us apply the zero product property, but the quadratic equation, as I'm showing it right now, help us to conclude the answer in an immediate way. I mean, we don't have to be solving all those steps. It's just like apply the formula and that's it. Okay, any question about this one? We can use that formula in the exercises you are trying, okay? Because at the end, solve quadratic equations, which is the other kind of equation we may focus on the class, are related with this procedure. So is it clear? Question, make it Eunice.
Sorry, it wouldn't be on the last one, where it says 5 minus 1 divided by 2. Wouldn't the answer be 2 instead of 4?
Oh, sorry. Yes, it's 2. It's true. Because it's 5 minus 1 is 4, and 4 divided by 2 is 2. Sorry. Wow. Thank you so much. I need some coffee, I think so. So here we have it. And yeah, it's almost time for the break. We have like some minutes. We have the two solutions, and it's so important that we check the two solutions. Suppose that I work with the 4, then I will have 4 squared, which is 16, minus 4 times 5, that is 20, plus 6, and this is supposed to make 0. It will not make 0. 16 minus 20 makes negative 4. And then negative 4 plus 6 makes 2, not 0. What a problem. That's why checking an answer is so important. So this topic is very easy to use. I mean, very easy to see if we're using this formula. Try to have this formula with you because you will see exercises related with this one. Okay. So we may go to the Jamboard again. And over there, we will see 2 exercises about it, but I think you already solved it. Okay, so I think you are very clear with this topic. You can solve it by using this formula. Even the guessing and checking you're using here, that's the method. That's how this method is called, guess and check. The one where you decompose and factorize one expression. Or let me help you if you're not clear with how to solve it. I see here many answers, okay? I see here many answers. And it's so good because I think you're clear with this topic. Because it's true, it's not the first time we see it. But if there's any question about it, you should make it. Like if you're not clear how this expression works like that, or why we can conclude an answer like this one, because we can solve it using the formula. So any question about it? Do you want that we solve the letter C or the letter D, one of those, by using the formula? No? Because you're clear with the topic.
Do it, please.
Which one, the C or the D?
The D.
Okay, let's go with the D and let's do it with the quadratic formula. I see over there that you fulfill everything like with the answers, with the procedure, and it is so good. So I'm gonna do it here. How can we solve this one? By using the quadratic formula. Quadratic formula is x equals to negative b plus or minus the square root of that value of b squared minus 4 times a times c divided by 2a. The situation is, from where do I get a, b, c? From where do I get these ones? Okay, I will get it from this variable expression that I have over here. I have ax squared, which is the general form every of these quadratic equation must have. Now, sometimes we don't have this value, for example. Sometimes there's no variable x. X squared should be always. If it's not there, it's not a quadratic equation. But sometimes we don't have that one. If we don't have it, then this one is 0. So at the end, the expression we have, which is x squared plus 12x minus 28, will let us understand or know what are the values of a, b, and c. What are the values of a, b, and c respectively? Can you tell me? Start with a. What is a?
1.
The number that goes with x squared. What
12.
is b? The number that goes with x. And what is c?
Negative 28.
The number that doesn't have variable. So if you already know what's a, b, and c, all that you have to do is replace it here. Again, my recommendation, when you substitute, when you replace in any equation, in any formula, use parentheses. So you may have negative times the 12 plus or minus the square root of 12 squared minus 4 times the value of a, which is 1, and the 28, which in this case is, and the value of c, which is negative 28. Okay, we'll see what happened then. Divided by 2 times the value of 1. Here it is. And if you see now, instead of work with variables, we forget about the variables and we just focus in work with numbers. This is how to use formulas. So here we have negative 12 plus, what is 12 squared? 12 times 12, right? Which is 140.
144.
Nice. What is negative 4 times 1 times negative 28?
112. Positive.
Positive 112. All these will be divided by 2 times 1, which is 2. So same in the other process, if you see, same as the other exercise, okay? We have those expressions working like this. In this case, the negative 12 over there. Yeah, I got negative 12 because this is negative sign. Multiplying it by positive 12, it makes it negative. Plus or minus. And let's see the result of this expression. What is 144 plus 112?
256.
256. What we should look in the calculator is if this 256 has an exactly root, and then we're gonna get or work with that exactly root. What is the root? Does it have exactly root or not? Does it have exactly square root?
16.
It's 16. So we may work these exercises this way. And I'm saying these exercises because here's where you get the two solutions you expect to have from a quadratic equation. What will happen? In what moment you will not have solution? Well, real solutions, because at the end we're focusing in real solutions. For example, suppose that instead of work 256, you have negative 256. Question to you, what is the square root of negative 256? Is it negative 6?
No.
No. What is the square root of negative 256 then?
That the first one, the answer is 2.
Okay, yeah, the answer here will be negative 12 plus 16 is 4 divided by 2 is 2. Yes, it's 2, not 4. Uh-huh. And the other one?
Negative 14.
Negative 14. Okay, you're right. And here we have the two solutions. But one question to you, what happened when you have a negative square root?
It doesn't have.
Okay, it doesn't have, listen, it doesn't have in real numbers. So no answer for this one in real numbers. And like we saw it with the equation, what you will say is that this one has no solution in real numbers because it has a solution in no other context of numbers. Of course, this is like go outside the real numbers and talk about the other kind of numbers that exist that I told you. There is missing one more set to talk about, and those are the complex numbers, okay? But we will not study those. We're gonna leave it over there. Okay, in these last minutes that we have, if there's no any other question about how to use the quadratic formula, any question about it? Is it clear now?
Yes.
Yes?
Yes.
Okay. We may go to this last part of this first part of the class, okay? And focus into solve those exercises. Here we want to have the variable expression and equation that will help us to solve the equation. At the end, that's what I want, that you create the equation to solve the exercise. More than solve the equation and more than solve the exercise is create the equation, because it's at the end the main objective of the class. Here you have the length of a rectangle is twice its width. Okay, sorry, that's its width. If the perimeter of the rectangle is 72 meters, find the length and width of the rectangle. So how can we create that variable expression or that equation that will help us to understand the exercise itself. If this one is 72 meters. So maybe use some formulas will help us. But there is something we may do. First of all, here you have the example of the rectangle. What is the length? What is the width of this one? Can somebody show it? Just can place like L or length, the word length and the word width. Because here comes the importance of the equations at the end. What we want to do to solve those problems. It doesn't let you work? Okay, here we have the length. And of course, this is the width. Question to you, is there any problem if I decide to work those any other way, length and width? Will it be a problem if I decide to work the length like the width and the width like the length? Yes, no, maybe. Well, for the rectangle, there's no problem. For other shapes, maybe yes, but for the rectangle, you can decide width or length however you want it. Now, what do we know about the length? What do we know about the width? Do we know the measurement of the length and the width?
No.
Is what we want to know. But we know something about the length. The length is twice the width. Let's make a supposition. Suppose the width is 10. What will be the length if the width is 10?
20.
20.
It will be 20, right? It have to be 20. Yes, because it's the double. Now, do we know the measurement of the width?
No.
No. And if we don't know the measurement of the width, what can we do in order to solve the problem? I mean, what do we use when we don't know something in mathematics? When we have an unknown in mathematics, what do we use?
A variable.
A variable. What variable should we use, Eunice?
X.
X, okay, yes. I was wondering, you told me like letter E. But no, we can't, right? Yesterday we say, why? Because it's a number.
Is the forbidden letter.
It's a forbidden letter. And the letter I too, and you say O. So here we have a width, X. If this measure X, how do I know the length will measure? Or how the measure will length? Listen to the question, how, not what. How the length will measure? How can we measure it? If
By
we know
dividing the perimeter.
But right now, is there any variable expression that let us understand that the length is twice the width? If the width is X, the length will be?
Y.
Excellent.
2x.
The double of X, 2X. So essentially here I have what I need, 2X. I have everything that I need in order to use or to create this exercise. And I told you many of the equations exercises are based on one model. Is there any model that let us know the perimeter of one rectangle? I mean, is there a formula that let us know the perimeter of the rectangle?
It's the addition of the four sides.
Excellent. And if this side in a rectangle that happened, right? And this is related with what will you do in the forum. In the forum, you will find or you will investigate some properties of shapes. For example, one property of the rectangle is that the measurement of the opposite side is the same. And if this side measures double of X, this side will measure double of X. And if this side measure X, what will be the measurement of this one? X. And like you say right now, Eunice say it, right? We have the perimeter, which is the addition of all the sides. You're right. So it will be, what is the perimeter measurement we have?
72 meters.
So we know that 72 meters is get from the addition of all those sides. Do I know the measurement of those sides? No. I just know that one side measure X, the other one measure X, the other measurement is 2X, and the other one will be 2X. If you see what do we have in here or what we have in here, it's an equation that you can solve. So solve it. You know how to solve it. Is it clear how to build the equation from this exercise? Because at the end, I just use the idea of perimeter. I have the perimeter, and I have the variable expression for the sides. It's so simple. It's so simple. Of course, like I told you, what we want to do with equations is create some models of variable expressions that will help us to solve a specific situation. With this one, I'm 100% sure you can solve the exercise because you can get the width, and with the width, you can get the length. Okay, so try to solve that exercise and try to create the variable expression for the other one. Try to create the equation for the other one. Just let me tell you that multiples of 5 should be written in one interesting way. When we talk about consecutive numbers, are numbers that are like next to each other. If you give me any value of n, any, you can tell me 13, then 13 plus 1 will give me 14, and those numbers are consecutive one. Okay, it's pretty simple to see it, right? But in the case of these kind of expressions, we may see how to get this one. It says the sum of two consecutive multiples of 5. It's 55. So I think you're trying to answer that one. So try to answer it, no problem. Okay. Wow, what happened? There he is. And we can get the answer of this one so easy. But the first thing is create the equation. Is it that students can normally solve those exercises just by guessing and checking or thinking the answer? Yes, some students do it like that. But the way to formalize the learning is with equations. I mean, sometimes this isn't a step that students jump. Some students jumps and some students need in order to see it, right? Okay, so it's practically time. I think that when we come back, we're gonna go with the last part of this class, which is focusing the geometry. And when we conclude the part of geometry, I think that we'll be done. This test is going to be one of the ones that is like with more contents, okay? And if you check in the WhatsApp group, I share over there how's gonna be the presentation of the project today in the afternoon. Here it is, if you couldn't see it. I'm gonna show it right now on the screen. I will give you 1 hour, like 1 hour, 20 minutes of the afternoon, and I will be in this meeting from 1 to 2. If there's any question, anything that you want to know about the project, okay? So right now it's 10 o'clock, and I hope to see you at 10:30. We're gonna come back and we're gonna conclude the topic of geometry, and that's gonna be, this is what the evaluation will be about in the test of tomorrow, with the topics of yesterday about polynomials, the topic of today about equations, especially linear equations and quadratic equations, and the part of geometry that is missing to conclude, okay? I think that we can go to our break.
Okay, thank you.